Hi, everyone. I'm sorry that I'm not here today, but we're going to still learn. Sorry, we're still going to learn the lesson that we were going to learn together, which is the last lesson before our review and test. So please open up your Unit 6, Exponentials, and go to the last thing in your notebook, which is called Day 12, Exponential Growth and Decay. Today, we're actually going to talk about the difference between growth and decay in the real life setting. And we're going to talk more about what the equation, specifically the components of the equation of the exponential, what they mean, all right, in the real life setting. All right, so here we go. So you should be looking at this, do now. It says which of the following could be the equation. So I know that we've already talked about the base, and if the base is less than 1, between 0 and 1 specifically, then it indicates decay. So this is a decay situation because from left to right, we have a negative slope. This indicates decay. So it's constantly decreasing. It's a negative slope to the tangent line. So because we know it's decay, we know that the base has to be a number between 0 and 1. Okay, so based on that, I'm hoping that you knew that you were going to be down to 1 or 2, because 3 and 4 are numbers that are bigger than 1 bases. So they're out. Then the next thing we want to do is look at the y-intercept. So the y-intercept is here, and you should see that it's a number between 0 and 5. Maybe it's like 3-ish. So based on that, I'm hoping that you realize that the answer is choice 2. Now, why is that the way? Well, the general equation of the exponential is the form that y equals ab to the x, where a is the y-intercept and b is the growth factor or decay factor. So first of all, we knew that it was decay, so that's why we chose a base that was less than 1. And also, we looked at the y-intercept and assumed that it was a number between 0 and 5, so that's why we picked an a value of 3. Now, could I have graphed these? Of course. So if you look at choice 1 and choice 2, I have choice 1 in y1 and choice 2 in y2. And if you hit graph, you're going to see that there is a difference in the steepness, okay? But specifically also, you can see a difference in the y-intercept. So choice 1 is the blue one. It has a y-intercept of 10. And choice 2 is the red one. It has a y-intercept of 3. Now, choice 2 is also a lot shallower than choice 1, and we're going to talk more about what that means right now. It actually has a less rate or a lower rate of decay. All right, so we're going to keep going here to exponential growth and decay. So you guys have seen this before in Algebra 1. So growth, quick sketch, should look kind of like this, where the a value is the y-intercept. And decay should look like this, where the a value is the y-intercept. Now, the growth factor, if it's growth, has to be greater than 1. If it's decay, the growth factor is a number between 0 and 1, a fraction or a decimal. Now, we can also break this down in terms of a real life setting. So the a, which is the y-intercept in the real life setting, is translated to a p. So the a is the growth factor. I'm sorry, the a is the y-intercept, not the growth factor. The b is the growth factor. And that's the case for both of these, growth and decay. As soon as we translate it to the second equation here, this is equation 1, equation 2, the a, the little a in the front, which is the y-intercept, gets changed to a p. Now that p is what we call the principal amount, okay? So if you look down below, it says P, principal amount. That's another name for initial amount. So if you think about the real life setting of like putting money in a bank, for example, when no time has passed, when x equals 0, no time has passed, what is the initial amount of money that you put in the bank? Let's say you put $100 in the bank to start your bank account, then the P would be the principal amount. or initial amount that you're putting in the bank. Okay. So when we talk about money, we use the word principal instead of initial. Same thing. Now, let's talk about this growth factor. Okay. 1 plus R or 1 minus R is the growth factor. If it is growth, which it is in this first column here, then the B is equal to 1 plus R, where R is the growth rate. So if you look down below, you see it says growth or decay rate. R is the rate, and you have to make it a decimal, okay? So let's say it was growing at 20%. I would have put in 1 plus 0.20, which is 1.20, and that would have been growth. So basically what that means is it's retaining 100% of its initial value, and then it's growing by 20%. Okay, so that's the growth. Decay would be 1 minus the rate. So the B is equal to 1 minus the rate. So this would be if you have a decimal or a fraction base, like let's say you had, let's say it was decaying by 20%, then it would be 1 minus 0.20. So then the base, which is the growth factor or decay factor, would be 0.80, which would mean that there's 80% of the substance that remains, but 20% of the substance decayed. So when you're looking at the decay factor, you want to consider that whatever you're looking at is actually what remains, not what part decayed. So let's look down below at all this notation. All right, so A is the same as P. That's the initial value or the y-intercept. These two are the same. They just have different notations depending on if it's money, then you use P. B is the growth or decay factor, and that's also the base of the exponential function, what's being raised to the exponent of t. And then x is the time or t is the time, depending on if we're using x or t. And then R is the rate. And just remember, it has to be a decimal, okay? So if it's in a percent form, we're going to make it a decimal. So let's look at some examples. Look at the next page. Number 1, for each of the examples below, identify the piece of information such as the initial value, the growth factor, and the growth rate, and then say if it's growth or decay. All right? So let's look at this first one. I'm hoping that you're thinking, all right, initial value is the number in front. So that's going to be 3. Growth factor, that's the number that's inside the parentheses. So that's the 1.7. I'm hoping you realize that since it's greater than 1, it's growth. So now what is the growth rate? Well, remember the growth factor is equal to 1 plus the rate. Okay, so if 1.7 is the growth factor, then I would have to subtract 1 in order to obtain the growth rate. Or you could just look at the decimal and look to the right of the decimal. But if you subtract 1, you're going to get the rate equals 0.7, also known as 70% growth. Okay, so for growth, you really can just look to the right of the decimal and you're going to see the 0.7. So that means that the rate is 0.7 or 70% growth. But if you wanted to, you could do the subtract 1 in order to get it. Now let's look at number 2. The initial value is not there. So if it's not there, what should it be? I'm hoping you're saying 1. Now the growth factor is actually really 0.8, so it's actually a decay factor because it's less than 1, because 0.8 is less than 1, right? So we have to figure out what the rate is, all right? Even though it says growth rate, it's okay if it's really decayed, all right? So if 80% remained, what percent decayed? Well, if I do subtract 1 from the growth factor, I'm going to get R equals negative 0.2. This means that it's really 20% decay. So if you write negative 0.2 growth, that's fine. Or if you write 20% decay, that's fine. But you can't write negative decay because then that's a double negative, all right? So basically just a reminder, you look at the base, you see what it says, and whatever there is what remains. So 80% remains, which means 20% decayed, because the baseline is like 100%. So we start at 1 or 100%. So you take away 20%, 80% remains. All right. Let's look at number 3. Here we have another base that's a fraction, so I'm hoping you already said decay. The base, the y-intercept is 1 because there's nothing in front. The growth factor is 1/4. As a decimal, that's 0.25. So because that's a decimal, 0.25 is less than 1. This is decay. So if 25% remains, what percent decayed? I said it already. You probably heard me. So if 0.25 is 1 plus r, if you take away 1, you're going to get r equals negative 0.75, which means that is 75% decay. So think about that in the form of chemistry. If there's a 1/4 here, this actually means 1/4 remains in the substance, which actually means 3/4 decayed, because they have to add up to 1 whole, or 4 out of 4. So 1/4 remains, 3/4 decayed, or 25% remains, 75% decayed. All right. So how is that connected now to the do now? Well, if you go back to the do now, you see that it was 0.75 here. So that would mean that 0.75 remains. So what percent decayed? Well, if you subtract 1, you get the rate is negative 0.25, or 25% decay. So that's like a shallower rate than choice 1. Choice 1, if you remember in my picture, if you see my graph, remember choice 1 was steeper. That was the blue one. And that's because that one had a growth factor of 0.5. So 0.5 remains, so 0.5 decayed, which means that was negative 50% decay, or negative 50% growth, which means 50% decay. So basically choice 1 decayed a lot more than choice 2, because that was 50% versus 25%. All right, let's go back to these practice questions here. So now we have some Regents questions. I thought we would do a few together, and then you guys could work on your own, because I think some of this is pretty straightforward. All right, so the first one says the initial value, the current population is 10,000. Now the population is increasing, so we're going to add our rate by 20% a year. So this is going to be changed to a decimal. So what is 20% as a decimal? I'm hoping you said it's 0.20. So when we set up our equation, we want to set up the equation y equals a b to the x, where a is the initial value. So the initial value is 10,000 times b. So the b is going to be 1 plus the rate, if it's growth, which it is, because it says it's increasing by 20% per year. So that's population growth. So we're going to do 1 plus the rate. So we're going to do 1 plus 0.20 to the x, or to the t. It says time, so we're going to do t. All right. So I'm hoping that you're looking at choice 3, because the growth factor is 1.2. And I'm hoping you immediately would have eliminated choice 1 and 2, because those have bases that indicate decay, because 0.2 is less than 1 and 0.8 is less than 1. So 1.2 means growth and 1.8 means growth. So you just need to know that if you add 1 plus the rate, it's going to be 1 plus 0.2, and that's why it was 1.2. All right. Let's look at number 2. 2 says depreciate. So that means decay, because it's going down. So if you know it's decay, if you look at the choices, you already see which ones are we down to. And I'm hoping you're going to say we're down to choice 1 and 3, because 1 is less than 1 and 3 is less than 1. So cross out 2 and 4. So we're going to write our equation y equals a b to the x. That's our basic equation every time. Y equals a b to the x. So the initial value is the 12,000. That's the purchase price of the car. So the starting amount. So that's the a. And then we're going to do 1 plus the rate or 1 minus the rate. So you're going to take your rate, which is 4.5%. You're going to make it a decimal. So if you make it a decimal, you move the 2 decimal points to the left. So it becomes 0.045. And we're going to do 1 minus 0.045, because the base is 1 plus the rate or 1 minus the rate. So if you do 1 minus 0.045, you're going to get 0.955. So the answer is choice 3, 0.955. Now let's go on to number 3. In the equation, blah represents the number of snowboarders in millions and X represents the number of years. Okay, so Y is the number of snowboarders in millions and X is years. Identify the initial value and the growth factor and explain what it means. So I'm going to give you a second to think about it. So pause the video and write down what you think is your initial value, and write down what your growth factor is, and write down what your growth rate is, and then write a quick sentence explaining. Okay, so pause. Okay, so I'm hoping you said that your initial value was 0.5, which is 0.5 of a million. So it said years since 1988. So basically that is the initial value of the number of snowboarders in millions in 1988. So the 0.5 of a million is really 500,000. So I said the initial number of snowboarders in millions in the year 1988, which is like T years since 1988, would be 0 years since 1988. So in the year 1988, the initial number of snowboarders was 0.5 of a million, or 500,000 snowboarders. And then the growth factor was greater than 1. It was 1.21. So that means if you subtract 1, you're going to get a growth rate of 21% per year. So, and it was growing at a rate of 21% per year, which is called an annual growth rate. Okay? So if you didn't write that down yet, please write that down now, and then we'll move on. So the next thing I want to talk to you guys about is the growth factor. Basically, it's really important to know the value, the real value of the growth factor based on if the X is alone. Okay, so what do I mean by that? Well, basically, the regular equation of the exponential is y equals a b to the x. If nothing has been transformed or translated, reflected, etc., dilated. So you never want anything except x or 1x in your exponent. If anything else is in your exponent, basically, if you look at the base, you want that to be the true value of the base. But if anything else is in your exponent, it's kind of a false perspective of what the base value really is. So for example, if you look at choice 1, you think that your base is 2, but it's really 2 to the 0.3 because there's really a 0.3 on the x or the t. So if I wanted to get the real value of the base, what I would do is I would raise the 2 to the 0.3 power, and then that would be the real base, which is 1.23. So if I had to rewrite this, this is really 1.23 to the t. And then I would see that it is still growth because it's still greater than 1, and it's growth by 23%, but basically it's not 2. So that's kind of tricky, okay? So looking at number 2, then you have to take the 1.2 and raise it to the third to get the t by itself, okay? You just want t by itself, or 1t. So go to your calculator and type in 1.2 caret 3, and you get 1.728. So if I had to rewrite this, it would be 1.728 to the t. So it's still growth, but it's just a different growth factor than you originally predicted. Now let's look at choice 3. We actually did this question maybe a week or a couple of days ago. So this is 1/2 to the negative 1. So if you look at 1/2, you think, oh, 1/2 means decay, but 1/2 to the negative 1 t really means 1/2 to the negative 1 times t. So you're going to take your 1/2 to the negative 1, and if you raise 1/2 to the negative 1, you could do it in your calculator if you don't trust yourself. But you guys should know that that means the reciprocal of the base. So you actually get 2, because this is really 2 over 1 to the 1t. So this is actually growth, even though you maybe thought it was decay because it was a 1/2. Because it's 1/2 to the negative 1, it's really 2. So this is also growth, so it's out. So the answer to this question was choice 4, 5 to the negative t, because if you change this to 5 to the negative 1 to the t, this is really going to be 1 over 5 to the t. Okay, so now the t is by itself, and now actually the base is fractional base, so it's 1/5. Now, could you have plugged them all in the calculator, graphed them all, and seen which one was decay? Of course. So, you know, I like to do everything algebraically with you guys, but it is important to note I could have just graphed all 4 choices, and I would have seen that choice 4 was the only one that went down, or decreased, indicating it was decay. But this is the algebraic way to do it, is basically you want your x or your t to be alone. So you want it to be a 1t or a 1x in the exponent, okay? You don't want anything except that when it comes to evaluating your base. That says 1t. All right, moving on to 5 then. So 5 was the Regents question. It said if m of t represents the mass of radium over time, determine if the function is growth or decay. All right, so first thing is we see an e. So just a reminder that e, remember we said yesterday, is an irrational number. And if you press second division sign and you hit enter, you're going to get 2.718, okay? So e is an irrational number and it's a constant. Let's just remind ourselves it's not a variable, okay? Now, if you think about it, you probably first say, oh, e is 2.718, so that means it's growth because it's greater than 1. But you have to remember that you have to take the whole base and raise it to the exponent, everything except for the t. So I want you to raise e, oh, let's get a pen again, raise e to the negative 0.693 over 1590. Because basically you want to do everything in the base raised to the exponent except for the t. Like leave that t on the outside. So you just care about this piece. So in your calculator, put in e caret fractional exponent negative 0.693 over 1590. And I want you to see if you get a number bigger than 1 or less than 1. Okay, so if you hit enter, do you see we got 0.9996? So is that less than 1 or bigger than 1? So a little less than 1. So is that growth or decay? It's decay. So this is decay because the base of e to the negative 0.693 over 1590 is less than 1. Decay. So some of you may have predicted that because if you know that 2.718 is a number greater than 1, when you raise that number greater than 1 to a negative exponent, it's going to become less than 1 because it's going to be reciprocated. So some of you might have said that and you could have explained it like that, right? Could you just have graphed it, by the way? Yes. So you could have gone to y equals, gone to 100 e, put the whole thing in the calculator. Sorry, 100 e 100 e caret fractional exponent negative 0.593 over, what was it? Forgot already. Negative 0.693 over 1590. And when you graph it, you're going to just see what it's doing, basically, if it's going up or down. But you got to put in the t. And then you're done. Sorry, everything is slower on this device. I apologize. Negative 0.693 over 1590 to the x. Hit graph or zoom 6. And if you can't see it, you could zoom out, which is zoom 3, enter, to see if you can see it decaying. And if you still can't see it, which it looks like I can't, you can go to the table. You could just look at the y values, and they're going down from 100 to 99-ish. They're going down over time. So it's decay. All right, so that's that. I want you guys to finish this worksheet now. Go down to number 6, try it. 6 is going to be just like the one I just did. You're just going to take your base, which is 2, and raise it to the exponent. Sorry, that was ugly. But basically, again, same thing. You're going to try this one, 2 to the negative 0.693, see if it's growth or decay. And then after that, you're going to go on to the practice and keep going. All right, thank you for listening, and I'll see you tomorrow.